Okay, welcome to Chapter 3, Lesson 7, Solve Systems of Equations by Graphing. Learning target or objective for this lesson is to solve systems of equations by graphing. Our one vocab word for this lesson is systems of equations. Two or more equations with the same set of variables. As always, you may pause the video to write down the definitions and then continue when you are ready. Okay, we're going to jump into an example. Solve the system y equals negative 2x minus 3 and y equals 2x plus 5. What we're looking for is to see if these two lines have something in common. If they have a point of intersection in common, that means that is our solution, the intersection point. That's what we're really trying to find. So these two lines intersect anywhere. And if so, then we'll double check them by putting that point into our equations. And if they equal out, that means that is our solution point. So first we're going to look to solve or write down our line y equals negative 2x minus 3. Okay, so now we're going to graph this one. And first we know the negative 3 is our y-intercept. So we're going to go down to negative 3, put our point right there. And knowing our formula, we know that y equals mx plus b. Our slope is in front of our x, so our slope is negative 2. So it's negative 2 over 1. So it rises negative 2, so it goes down 2, then over 1. So we're going to go down 2 over 1, down 2 over 1, down 2 over 1. Let's just go the other way just to make sure. This time we're going to go up 2 and over 1. Up 2 and over 1 because we're going the opposite way. Okay, we got enough points there. Now let's sketch as best as we possibly can. Okay, now we're going to try to look at our y equals 2x plus 5. Now, knowing our equation, y equals 2x plus 5, we know 5 is our y-intercept. So we're going to go up to 5. And make a point there. And now we know our slope, once again, is in front of the x. It's a positive 2, so we know it's going from left to right, it's going up. So it's going to go up 2 over 1, up 2 over 1. And now we got to try to see if it intersects someplace. So we can go down 2 over 1. It's going the opposite way. And we'll draw that line. Okay, it looks like we might have a solution here. It's right about there. And here's where you sort of do a little bit of guessing sometimes. Looks like it's at our negative 2 up 1, so it's at point negative 2, 1. And here's where you can double check your answer to make sure it is correct. We're just going to plug it back in those points into our formulas, those coordinates into our formula. Our y is 1. And we have a negative 2, and our x is negative 2 minus 3. So we have negative 2 times negative 2, which is a positive 4, minus 3, and it equals 1. 1 equals 4 minus 3 equals 1. Works for that line, so that line looks good. Let's go down to our other formula. We have y, which is our 1, equals 2, times x, which is negative 2, plus 5. So we have 1 equals 2 times negative 2 is a negative 4, plus 5. Negative 4 plus 5 is 1, and that works out well. So that is our solution. Our solution to our two lines is negative 2, 1. When doing this by graphing, you're always going to have coordinate points. So your answer is not just 1, it's negative 2, 1. Make sure you do that and write them in coordinate form. Okay, let's jump to our next slide. As always, if you have any questions, please write them down on your video sheets. Bring them into class or redo the video to see if you can possibly get some more help that way as well. Okay, we're going to jump into a real-world solution. Greg's Motorsports has motorcycles which have 2 wheels and ATVs, 4 wheels, and stock. The store has a total of 45 vehicles that together have 130 wheels. Write a system of equations that represent the situation. Solve the systems of equation. Interpret the solution. So first of all, we have to write some equations down. Once again, we did this in chapter 2, writing equations from words. So Greg has motorcycles, 2 wheels. Let's make motorcycles Y, and ATVs are X's. So we know our Y's plus our X's equal 45. That takes care of our vehicles. And they also gave us numbers for wheels. He gives 130 wheels. And we know motorcycles has 2 wheels. So for every Y we have, we're going to multiply it times 2 for our wheels. And then our ATVs, we know that has 4 wheels. So every ATV we have, we're going to multiply it times 4, and that's going to give us all of our wheels. And there are our system equations that represent the situation. There you go. Now we have to solve it. But to solve it, we need to put it in a little bit more workable form that we have been using. So slope-intercept form. Once again, our slope-intercept form is y equals mx plus b. So let's just make them look like that. So our first one, y plus x equals 45. Have to get y by itself. That means we have to move the x. In order to move the x, do the opposite as a plus x, so we're going to subtract x from each side. So our equation should look like y negative x plus 45. Now our second one. First of all, we have to get everything away from y. So let's subtract the 4x from both sides. Get you 2y equals negative 4x plus 130. We're going to divide everything by 2. So negative 2x plus 65. And there's our 2 formulas now. So looking at this right away, if we just look at our formulas, look at our slopes always first. They're negative. That means going from left to right, our slope's going to be going down. And then it also gives us our y-intercepts of 45 and 65. Okay, moving along now. Now we have our systems of equations. Now we're going to solve them. So once again, we're going to graph each one. So we have our y equals negative x plus 45. So we know our y-intercept is 45. We'll put a mark over here, 45. And if we put in y equals negative x plus 45. Let's put in 0 for y, so we get our x coordinate. So we have 0 equals negative x plus 45. We'll add x to both sides. X equals 45. So we're going to plug 45 in right there. And now we're going to solve our other one. We're going to graph it. Y equals negative 2x plus 65. Well, first of all, we know our y-intercept is 65, so we'll put a green dot there on 65. Now we have to see where our x-coordinate is going to be. So we have y equals negative 2x, 65. Put 0 in for y. Let's get x positive. We'll move x to the other side. That gets it 2x equals 65. Divide x by 2. And we're going to get about 32 and a half. 32 and a half. Right about there. So now we'll match up our lines best as we can. Okay, so it looks like it's right about there. Going up, looks like it's 20. at 25. And as always, we can double check our answer as we're sort of estimating where the line is. We can plug it back into our first equations that we had. So we know our x is 20, so we got 20 plus 25 equals 45, so we know that's true. And now we have our 2 times 25 plus 4 times 20 equals 130. 2 times 25 is 50, plus 4 times 20 is 80, equals 130. 50 plus 80 equals 130, so that is our solution to it. Shows on our graph the number of ATVs and number of motorcycles at the store. So it shows we have, remember ATVs are x-axis, so it shows we have 20 ATVs and 25 motorcycles. Okay, we have a number of solutions. As the lines intersect, there's one solution. As in our last two examples, we've had one intersection point, and we've proven that by double checking it into our equations. So there's one solution. What happens if our lines are parallel? Lines are parallel, that means they don't intersect. It means there is no solution. There is no crossing point. And what happens if the lines overlap? They're right on top of each other. That means there's an infinite number of solutions. That means every point along that line is a solution. I'll look at a couple more examples. And we're going to solve by graphing once again. So we have y equals 2x plus 1. Once again, our 1 is our y-intercept. And our 2 tells us our slope. It's a plus, it's rise over run, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And we'll just draw that. Okay. Take a peek at another one. Our y-intercept is -3. 1, 2, 3. And our slope is a +2 as well. So up 2 over 1, up 2 over 1, 1, up 2 over 1. Looking at that solution. Okay, taking a look at that. That looks pretty parallel to me. I don't see where they'd intersect. So our solution for that would be, actually, there is no solution. Parallel lines. If you have any questions, please write them down, as we will go over them in class. And let's hit one more example for this lesson. We have y equals 2x plus 1. Our y-intercept is 1. The number in front of the x, coefficient in front of the x, tells us our slope, which is a +2. That means it's 2 over 1, so it goes rises up 2 over 1, rises up 2 over 1, up 2 over 1. Let's draw a line best we can. And let's take a peek at our other one. We have y minus 3 equals 2x is 2. So let's get that in slope-intercept form. So let's get y by itself. So we're going to add 3 to both sides. We get y equals 2x plus 1. Y equals 2x plus 1. Looks like the same thing as we had right there. That means our lines are going to be right over top of each other. They're going to lie right on top of each other. So that means we have an infinite solution, infinite number. Every number, every point on the line is going to be a solution for that graph. Any questions, please write them down, bring them into class as this concludes this lesson.